OffNote Labs talk series, we invite industry experts, researchers, and builders who are passionate to share their learnings and experience with us. And it's sort of a blend of traditional presentation and podcast style conversations. So you'll see questions on the fly and discussions. And typically, our audience has been very technically engaged, so it gets very interesting as people go deep into the topic and try to understand things more deeply. And we take delight in unraveling the experience of doing research and innovation. And that's part of the broader theme of OffNote Labs. So with that, I'm very happy and excited to have Vikram and Rishubh as speakers today and talk about their awesome work at ShareChat involving understanding videos and text at a huge scale. So over to you, Vikram and Rishubh.
Yeah. Okay, guys, you can hear me?
Yes.
Okay. Thank you, Nishant, for the wonderful introduction, and thank you guys for making out time on Saturday morning. It has been hard for me, so I understand a lot of you might have taken extra care last night. So let's keep it very, very interactive, right? And we'll try to go into the research topics that we look at. But before that, we'll just give you some idea of what we do, what are the main challenges that we face. Okay, so some of you might know that ShareChat has two main apps. One is the ShareChat app, and other is the Moj app. And in the coming slides, I'll just explain what these two apps do. So the agenda for today will be an overview of the apps that we have. Then the two most important topic that we look at. One is the content moderation, where we try to address trust and safety issues on our platform, and the other is nearby recommendation engines. So I'll explain what cold start problem is in the coming slides, and then we have like few sections which will be very, very interesting for all the folks here, because here we'll talk about how we try to productionize these systems, right? So while in research and in papers you could very well do a lot of things, but when you want to really put it in production, you need to be very sure that they run at the scale you want them to run at. Moreover, you can also understand that data becomes a very important part in production, right? Unlike research, where your data sets are already curated, here that is also an important factor to think about. Okay, so before that, just want to touch upon this point of Bharat. Okay, so what we call Bharat here is in the context of the people who have joined internet recently. So if you imagine somebody at your hometown or in a village, you would realize that a lot of people have started using internet just like probably a couple of years back, right? And they're not too tech savvy yet, but they have still, because of the penetration of internet and mobile phones, they are on the net now. And there are some very peculiar characteristics of these folks, right? One is that they love to discuss things in their own language, right? So they're not English first user. If you see like my parents and all, I mean, they would speak to Google, Alexa and everything in Hindi, and they will also type in Hindi sometimes in WhatsApp also, right? So the content that they prefer is not a English first content, unlike a lot of us here. The other thing you could see, and maybe sometimes we also smile at it, is that the things they search for. So while a lot of us may not search for Krishi Darshan, right? I mean, or farming, but that forms a very important part of a lot of people's life in India. Similarly, astrology, religion, some things, these are not the things which typical for English first user will do on a day-to-day basis. So we have to understand that these people have little different taste and different needs, right? The other thing is that they love simple things. So this is not unique to Bharat users as such. Everybody will love simple things. But what is happening is that we as a user who have been on the internet for last 10 years, what is simple for us may not be simple for others, right? If you see LinkedIn or if you see Facebook, if you see that triple menu buttons there, a full dashboard comes up, right? There's so many options to take care of. But just think about it. I mean, do you think your parents would not be understanding all of it? No, right? So they would love to have something very simple wherein they can just come in and things automatically flow in the right direction. And that is where we feel that AI can help. So AI can, push the right content to the users in a safe way without doing too much of operations, right? So you don't need to really follow people, you don't need to search for people, you don't need to have a lot of friends. It's just a very, very relevant content that comes automatically on your screen. That is what our both our apps try to do. So the overall objective here is that we want our users to be able to discover content which they can consume themselves as well as share it with others. We want them to have fun. We don't want it to be a boring app where it's just about content information. It's also about fun. We want them to be informed, so we have a lot of news data over the our applications, and we want to have them build some kind of community wherein they can meet with people with similar interest. So with these things, we are trying to develop these applications which are little bit more focused for Bharat, like the first ShareChat app that I'll introduce, and Moj, the other app, is more unique in that sense. It is very, very applicable universally. So what is ShareChat? This is the first app that I want to talk about. So this is exactly for the language first audience. So we see that the majority of people on ShareChat, they're not English users, they are mainly users in the other Indian languages. So here you can come, you can share content, you can discover new content, and you can form communities here. So currently I just want to say that we have around 50 languages here, and we have around 30 minutes that users are spending every single day. So that's a very, very phenomenal number for us, that 30 minutes of their day people are giving us. And that makes us more responsible towards giving them the right content. Our monthly active users is around 160 million plus now. So the app is doing pretty good, and we are receiving around 2.5 million content pieces every day. So a lot of content is getting created, a lot of content is getting consumed by the users on this app. So the other app that we have is the Moj app. So this is a short video app. So here you can only upload videos, and these small videos can be consumed and they have their own categories. So we would like you to see these videos and serve them in the right way so that all the interesting video comes to you. So here also, if you see, I mean, we just launched it few months back and we already have 80 million plus MAU over this, and 2 billion plus videos have been playing every day. So imagine the kind of interaction that people are having, and these are pretty fun videos. I mean, just play one for you, and
गंगू चांद थी और चांद ही रहेगी.
Right, so it's just some fun content, right? So it's not a very, very utility based thing, it's more for your enjoyment, but we're trying to make it as useful for you as possible, right? So these two apps form, let's say, the pillar of ShareChat currently, and we are trying to make them better every day. So one of the biggest difference I think we have tried to create here is that we have tried to move from connection oriented to AI first feeds. Okay, so I think the figure that you're seeing right now, okay, so this is a typical figure which a lot of social media apps use, wherein you have to add people in your network. Once enough people are added to your network, you start getting good number of feeds, a good number of videos, okay, and they are relevant to you. So in this, what happens, the AI comes in and it starts improving the overall experience, right? Something like Facebook, right? But what we do at ShareChat is, from the connection oriented, we have moved to AI first. So the idea is that maybe you do not need to add anybody. Maybe you can just come on the platform, we start showing you some videos, and after a few views, we'll judge what you want to look at and then start recommending similar things. That is how our apps work. So when you add, there is no inertia of finding people to be added. So what this does is, this solves two important purposes. First is, connecting people takes time, right? So if you are, let's say, an introvert person, you will not be able to really do so well on maybe Facebook. You will not be able to add enough people, you will not be able to follow enough people, and you will just get bored and out of the network. The other thing, if you see, is from the people who are creating content. So what happens is, in Facebook and all that, since you have added people, anybody who you do not know, his content never comes to you. So what happens, you lose out on a lot of nice data, right? So let's say your friends are all philosophers, right? And you are interested in cricket. Now, if you just keep following those philosophers, like I do a lot of researchers, so I find my whole feed with CPR papers, and I have none, right, in this year. So what happens, it gets very, very boring at times. So at times what happens is, the app should be able to do what I'm trying to do right now, not what my friends do. and that is where this AI first feeds start helping us. So it helps both the people in finding right content, and it also helps the people who are creating the content to reach the right person. So this is a major shift in the understanding between the other social media platforms and what we are trying to do. So now,
So let me just leap in and ask. So the content that you get on Moj, is it different from what people used to post on TikTok, or is it more local or Indian in some way than?
yes, yes. So it is lot Indian actually. So the format is similar. I would say they are short videos, but you can imagine that everybody is posting their own language, and the followers that they are getting is lot from their own state, their own region. So it's pretty interesting to see that kind of thing. And we also do sometimes this heat map across north, south, east, and west India, and we realize like how differently people are interacting with different content. So different thing is famous in different area.
So there are sort of local clusters that are emerging across.
Yes, yes. And I think it depends on what festival is happening. Right. So when IPL started happening, then suddenly we saw a lot of cricket videos. So the trend keeps on changing. I mean, it's a very, very live kind of feed. So it's moving thing. Yeah.
Just to remind everybody, there's a chat box where you can type in questions as we go into the talk. And if you want to raise your hand and ask, that's also fine.
Yeah. In fact, I would love to stop for me 10 seconds if somebody wants to ask already something. I mean, let's keep it interactive. I mean, otherwise there's no fun.
Yeah. So a quick reminder that this is a virtual platform, and it's not the same as having Vikram and Rishubh in front of you, but there's a slight push that's needed for you to start asking questions, and once people start, it's very interactive. So please go ahead and throw your questions, small, big, anything.
Okay, no worries. So I'll start.
Sure, you can continue.
Yeah, and then guys, you can just ping me, okay? Like ping in the box, and we'll take it from there. Okay, so the main things that form the important parts at ShareChat is one is recommendation systems, right? So since we are an AI first company and we are not having this connection based thing, you can imagine that recommendation is the only thing that pushes one video after the other. So that forms an important part. The other important part is content moderation. So guys, when you open a dashboard or a platform to everybody, then you can understand a lot of people will start posting offensive content, and there will be a lot of fake news like what Twitter is facing right now. So content moderation is very important given the environment that we are living in these days, right? And it's changing very drastically. Every other day you see new laws coming up from the IT Ministry of India also, right? It's an ongoing topic. So that's why it's very important. The other is cold start problem in content streaming, because recommendation systems don't really work so well when the content has not been shown to enough people. I'll go in detail in the coming slides on this. Other important thing is creator tools. So whoever is posting videos on our platform, our creators, we want to help them create better videos, high quality videos without doing too much of effort. Then we have operations team, which is very important because there's so much of content coming every day. We need a lot of people to understand it and moderate it. And then we have the AI platform and deployment. So since like 2 million posts are coming every day on March, so you have to do everything at scale. So we'll also cover how we try to make this happen in a speed and latency point of view also, right? So the first thing that went out, content moderation. So as I explained, I mean, since a lot of data is coming, content moderation is very, very important. So at ShareChat, we internally call this as integrity violating content, because it is not allowing us to really maintain a clean, safe environment for our users. Yeah, Rohit, I see the question. Yeah, we'll cover it after explaining the content moderation. Okay.
So Rohit is curious about how accurate your AI has been for content.
Yes.
And we'll go into that. Yeah.
Yes, we'll go into that. So I'll just explain the methods that we have, and we'll explain that. Okay. So usually, I mean, there are few categories of IVC content that we see. I mean, a lot of violence, nudity, gore, engagement baits, where people just give you that click here to do this, click here that. So these are not actually good content, right? If you are on a platform like Moj or ShareChat, you would not like to see all of this. But the reason why people do this is because this gives them views, right? So all the sensational content usually gives more views. So it solves the purpose of the user because he gets views and followership, but it it does not serve the purpose. We are not here to serve you this content, right? So we need to stop it, right? So we try to. So one thing that we started initially was when we had less number of data points was that do some manual examination, but this cannot work, right? Because a lot of posts. So now we have developed algorithms which can work along with the human moderators in tandem. So we have designed this, some content moderation policies at ShareChat. So there are three main policies. One is proactive. So what we do, every video that comes in goes through a IVC detector. So there is this model which is able to look at the data and say whether it is a bad content or a good content. So if the model is very, very sure.
Sorry, you use the term IVC.
Yes. Yeah. So IVC is integrity violating content. So we like all of this content we cover in one umbrella term. So if the model says that this is definitely IVC, we ban the comment or we ban that post. Sometimes we also try to ban the whole profile if we see a lot of content coming from that. But if the model is not very sure, then what we do, we pass it through a human moderation pipeline. Okay, so it goes to an annotator or an ops team person who will look at it and tell you whether this is actually IVC or not. So now this also helps us as a annotation tool, if you understand, right? So what happens, any tool with which model is not very sure, that goes through now an automatic annotation process, and next time when we train the model, this data automatically feeds in. The other approach that we take is reactive approach. So any post that gets famous on the platform, we definitely trigger this thing, because virality is such a thing that it can happen for any random thing also. And so what we do, like we wait for, let's say, 10,000 views. Once those views come in, we say, okay, let's get it checked why that is happening. So if the content is good, we'll let it pass, otherwise we'll block it. The third one is user triggered. So we have this report abuse kind of options in the app. So that is the third channel from which this can happen. Okay, so I'll just take some questions here. Yeah.
Pause a bit and
Yeah.
people, please ask your questions.
Yeah.
This is probably the high level flow chart of their IVF detection flow.
Yeah.
And I believe they'll get more details.
Yeah. So I'll try to answer first question. So Rohit, you asked about accuracy. So it's very interesting. Okay. So this content accuracy, so we don't measure accuracy at times, right? We measure a lot of times the recall. So the idea with IVC detection is that we do not want any post to get missed, but we are very much okay if more candidates come in, right? So we don't want any post to get missed, because if that is missed, then it goes into the platform and becomes maybe viral. So we measure everything into recall now. And our recall values, I think Rishubh can point on the exact values here, and Rishubh, do you want to just take this?
Yeah, right. So we have recall values of more than 90 to 93, but again, like for remaining posts, it also goes for manual review. So it doesn't happen so if anything is missed by the model, still we have some manual moderators that can detect the post and remove from the platform.
Yeah, thank you, Rishubh. So guys, so basically it's a combination of all these three strategies that we are putting here, because it's a very tough thing to do IVC detection, right? I mean, it's very contextual. So we try to do this, and over a time we keep on measuring how many percentage of posts we were able to capture. So that helps us is knowing that whether we are capturing or not. So let's say on some day if it is 0, then definitely we have missed a lot of things. Okay, and then whatever recommendation algorithm. Recommendation, guys, I think we are not probably the subject matter expert here. So we will talk in a different direction in the coming slides. And for recommendation, I think we can connect you with the right people who are developing recommendations. So we have different verticals. So we are from the content understanding vertical more than the recommendation part. Okay. And Rohit, what happens when a celebrity with multiple followers posts some IVC? So guys, see, if somebody report abuses, then we definitely have a look. And to be honest, a celebrity would hardly do this, right? I mean, can you imagine a popular person putting their reputation on stake? No, right? So it happens very, very occasionally. And in those situations, the post is, we don't remove the account, honestly. So it's not that high penalized for a popular celebrity. We will ask for a reason and then take it forward from there. When you say model is not sure, Ayush asked, do you mean to say model confidence? So guys, there are two ways, right? So when you say model is not sure, one is the measurement of entropy, right? You can say if the entropy is high, then the model is confused. The other way of looking at it could be what is the probability of the best possible class. So you can have a threshold. You can say that if the maximum probability is above 0.9, then that is a measure of confidence, right? And the third thing could be, people do this ratio of top to probability. So top one by top two. So you see how much the top is better than the second one, right? And then I think all of you might also have heard about this uncertainty paradigm, which we have not started yet. But that is also another way of looking at these things. So there are a lot of these things, and it is a little bit empirical, Ayush. So if you ask me now what is the value that could work, I mean, it could be anything, depending upon how your models are confident, what kind of data you fed them with, right? So you have to do some calibration there. Recall meaning how many people have viewed. No, so recall does not. So in this context, when I said recall, it meant that if 100 IVC posts were uploaded on the platform, how many of them we were able to bring? Basically, how many of them we were able to identify, right? So if you have a relaxed system, what it will do, it will miss some of the things. But in our system, what we say, okay, bring in more posts, but do not miss any IPC. Okay. And Ayush, recall means total correct valuation. Ayush, I'm not very clear about your next question. Can you just type it again? I mean, a little bit more explanation. Yeah. Yadnesh, what happens in the proactive part? Are there single models? Yes, we'll talk about the models in the next section. Yeah.
Sorry. Yeah, it might be a good idea to just read through all the questions and then maybe you can answer them together.
Okay, yeah. Yeah, so about guys, I think about the content moderation models, we have a lot of slides for that. We'll cover it in the next section, exact models also. How has Moj been successful in training AI models in 15 different languages? So I think one of the major bottleneck is data, right? Most of the time. So it's no big deal to train 15. The big deal is getting the right content. And fortunately, I mean, we have so many users right now across different part of the place in the India that we are getting data across all the languages. So in that way, we are little, you can say, fortunate. Like the data is not an issue for us. That's why we are able to train it. Yeah.
But I guess the challenge is the labeled data.
Yes, so we have a slide for that. Yes, so we tell how we try to use unlabeled data. So we have a lot of unlabeled data. Let us wait for that. I think Rishubh will cover it in more detail. Okay, so guys, I'll just move forward and then again I'll take the questions from this point onwards. Okay. Right. So in this slide, I just want to cover why off-the-shelf solutions do not work. So Google has its own API for offensive content. Amazon has it. Right. So we tried them actually, but what happens is that the policies, what is an IVC content keeps on changing because as the platform is growing, we are seeing a lot of different things, and as the laws are changing, it will also change, right? Another important part is explainability. So when we have our internal models, we are able to explain why this was an IVC content. So when you use IVC, we do not do yes or no. We also try to find out whether it was violence, gore, or what. So that way, once you explain it, you can tell your users also, right, that why this post was banned. Because our users are new, they are creating content and they are not professional users, so they might not know why it got banned. So this also is important. Third part, what I think you guys have already recognized the problem now. So it's multimodal data. So not everybody does multimodal, and the kind of audio video that people get is very different. Other thing, culture and geography, right? So a lot of movies, which are probably adult in Indian context, are not adult in US context. So what happens if you take their models? They may not generalize so well to your geography and your culture. Other thing is creator profiles. So the people who create good content never do these kind of IVC violations. So this is also an important thing. If you take off-the-shelf solutions, they would not be able to take the signals from your own platform, right? And then we see people are finding new ways to game the system. So people are trying to manipulate in such a way that it comes negative. So we have to keep on, having our own models which can improve over the course of time so that we can handle things well. If we rely on any third party, they will not be able to update with the kind of trends that we see. Okay. Other important problem, I think, which is very common among users in general, including us, maybe sometimes, is that deduplication. So any post that gets too many views, people tend to, instead of resharing, they tend to download it and put it again from their own, profile. I think we all might have done it at some point on LinkedIn or Facebook, right? We like something too much and then we write it from our site again instead of resharing it. So what happens in this scenario is that this post, because its quality was high, gets spread across, and the user starts seeing the same post multiple times, right? Because this is the exact same video, and since our recommendations are AI based, both these videos will have very similar kind of response by the users. So this is not a good user experience. So we need to remove the duplicate post from our platform. Okay, but for that we extract the features from the post, and then we have to do nearest neighbor search. But the problem here is time complexity and space complexity, right? So when 2 million posts are coming every day, in a month you can just see, I mean, how many posts we have. And if I have to find out whether this post is duplicate or not, I have to compare it with all of these embeddings, right? So like for one day, let's say you got 2 million posts, then your embedding size of, let's say, some 100 or 512 will be there, and you have to compare with 2 million posts every day. So that is very, very time and space complexity. So, and the other problem is that will, because of the time, this duplicate post will spread in the network already. By the time you recognize it is duplicate, it will spread off. So that is why we try to use some of the software tools like Milverse and Fires. So these tools are give you GPU acceleration also, and they help us in doing a very fast nearest neighbor search. Okay, so just to give you some context, like how can you speed up your search, right? So what you can do is you can cluster your embeddings. So instead of having all the embeddings of all the posts in one flat index, you can make clusters. And when a new post comes in, you can see its distance with the centroid of a cluster, and then do a deeper search into that cluster. And then this hierarchy could go on depending upon how fast you want it to be. The other way could be that you reduce the precision. So instead of having floating point, you can just have integers. So now, although your accuracy will be down, but your search will be very fast. So these tools inherently try to use these techniques to give us a very fast nearest neighbor search. So I think anybody who has worked on clustering would know this, right? So if I give you 10 million images with ResNet features 2048, it's very difficult to cluster them. If you do k-means, it will take ages for a CPU to do it. And that's where these kind of things help us, because they are very fast in computing distances between the data points. Okay.
The other issue is that actually the similarity between two embeddings matches the semantic similarity of the post with the images. So were you successful doing that? Are you going to talk about that more?
So yeah, so this we are very, very successful. I mean, so we have been, because see, what happens is that if the post is same, then even if you take few frames out of it, the embeddings will be exactly same, right? So it's not that tough a problem.
You're talking only about video right now.
You can concatenate audio video together.
Well, no, and text.
Text also. So when we are talking, we are just talking about one modality for concreteness, but you can imagine you can just concatenate everything.
So your higher level claim is that even if you remove part of the some sub part of the whatever mode it is, the embedding will be really the same.
Yes.
And you don't face like with text there is this paraphrasing problem. The text is not the same, but meaning is the same.
Yeah.
So you don't you encounter less of that kind of problem.
So we don't want to do that. So if you are expressing the same content in different language and you have made your own video, we are fine with it. So we want to only penalize exactly same upload. We want to avoid re-uploads, right? So it's not a paraphrasing or entailment problem. It's more of an exact match problem. That's why it becomes easier. But I understand, Nishant, your point is very valid. If you want to have similar videos, that is the whole problem that we face in recommendation. In recommendation, we would like to have the same paraphrased, text maybe shown to the user one after the other. But here the problem is a little different. Here the major problem is the problem of scale.
And the encodings, the neural architectures that encode these are standard.
Yes, for this we use very pretty standard ones. Yes, and we even quantize it. So we just use maybe like 8-bit or something, and it's able to give us the exact duplicate for sure. Right? So, and this is very important because this needs to happen very fast. because once that post is shown to some people, so let's say if post is done today and you take 1 hour to find out if it is duplicate or not, by the time it would be so viral already, it would have already deteriorated the experience of lot of users.
So is there a pre-filtering strategy before you post? Pass it through some embeddings and match. How
Yes,
does it?
yes. So as soon as the post comes in, our IVC pipeline, deduplication, these are like very, very sanity pipelines. I mean, they run first before anything happens. These have to finish within seconds, and then there could be some batch thing which can happen overnight also.
And I guess then you have to talk about, or I don't know, you'll talk about the infrastructure that handles this at scale. You get too many, I don't know how many posts per second, and all of that has to be processed at a millisecond.
Yeah. So we see even normally in the morning, like 9 to 12, a lot of posts suddenly come in, and evening 9 to 12, and which is understandable, right? So I don't understand the mornings, I understand the evenings. So somehow some people do it in the morning, and I'm not sure. Maybe this is their profession. So maybe they promise themselves that every day I'll do one post, and that's why in the morning it happens.
Yes.
But evening is pretty obvious. So
sounds good. There are one or two questions. Oh, sorry, there are more questions. Just don't scroll as freely I used to do. There are a couple of questions. So maybe you can read through all the questions. You can decide to answer now or at a later point.
Yeah, so I think Sriram, I think you asked a very important question: is it better to optimize precision? So the thing is, it depends on a policy, right? So when you go for precision, you have a low recall, right? There's always this AUC curve and a pros and con there. We don't want any bad content on the platform. We are very much okay in stopping a good content, but not letting a bad content, right? So that is the choice we have taken. And since there is a manual thing also, so precision automatically goes high, right? So we bring in more candidates and then subsample it using humans or using confidence value. So it works out that way. What step did you take to reduce the data usage? Yeah, data usage, I think Raki, I'll probably try to answer a little later, because that is a very so can you just specify, like, do you want to know in product sense, or because this data is on servers and it gets pulled up when you want to look at it. So there is no and there's a lot of encoding decoding of videos, of course, so I'm not sure if you're talking that direction, but just can you just rephrase the question, let us know which direction you want to understand it from. And Siddhartha have to, yes, Siddharth. So this so duplicate can be done using Siamese network, you're right, okay, but this just works, right? So when you say hashes or signature, it is like an embedding, right? So it's pretty similar thing. I mean, I would not. So when you say Siamese, it needs to be trained for your data. But here, for duplicate, even if you take a pre-trained network like ResNet, it will give you exact same embedding for the exact same content, right? So no issues there. Yeah, Honesh. So Honesh, we'll talk about the concatenations and everything in the coming slides. Okay, that's a major section. We'll just take it up. So the deduplication happens over a certain period. Okay, so it's a very valid question, Sriram. So we cannot store months of data. So we have this rolling window on which we find the deduplication. So deduplication is supervised, unsupervised. So there's no training. I mean, we just take features and you can say nearest neighbor. So it can be called as an unsupervised mechanism. Yeah. In scaling, Pratik, I think this you just check out this Milvers and Fires. So these are the tools for exactly this scaling part. Okay, so it was not too hard to do that. So and we all use Google Cloud Platform, so we have the scaling there inbuilt. So it's not a big deal to do that. It's just a config changes. Right? So that's not a major bottleneck for us right now. So I'll quickly move to the next thing. I mean, so
yeah, I just to add a note that it seems that your unique use case is about adding stuff and removing from this embedding database of Milvers or Fires, because you want to work over a window. Is that right? So you have to remove stuff from the previous window, or you just split the shards in such a way.
Yeah. So the Milvers and these approaches, they're fantastic in this. So they give you an option of setting up the time. So they will automatically, let's say, the stack will be there. It will be once something gets pushed, queue will be there, and it will be just pushed back out of the queue once new thing comes in. Yes. So yeah. So
handle some of the
yeah. So I think we try a lot to not reinvent the wheel. I mean, we could have written all of this ourselves, but it's just not probably worth it. I mean, these solutions are open source. You can use them and check whether they work or not. Unless you really need something new, you should probably try to use them as it is and then see what happens. Right. And so this is an important topic. So as we mentioned earlier, we try to do AI feeds, right? So everything that you see comes through AI. So recommendation is a very important part. And what recommendation means is how to surface the content, right? What video to show is recommendation. And this becomes really, really difficult in the early part of the life cycle of a post. Okay. So you see that recommendation engines start working very well once enough people have seen the content, right? Then the recommendation knows that this person likes this person likes this. That is why I can show you that. But when you land on, let's say, Netflix for the first day, it is not able to recommend you anything. Because from user point of view, it's a cold start. They have not seen you seeing any video yet. So they will show you some popular things, right? So that is where we also face a lot of difficulty with the life cycle of a post, right? So just explain you here that with this example, that let's say there are two people, okay, both like pizza and salad. So the algorithm might have said they are similar person. But when, let's say, a new thing comes in, let's say this is Coke, then because the person in blue consumed Coke and the person on cycle and blue are similar, you can show this Coke to the person on cycle also. That is how recommendation works. It says if people are similar, if one of them consumes something, the similar would also like to do that, right? But in order to do this, the person in blue has to consume this cold drink, right? If he would not have consumed, then we would not have known who to show this cold drink for to, right? And that's what happens with our post. When a new post comes in, we do not know, because it has not been shown to anybody, we do not know what kind of people will like it. Okay, so this is one major problem with recommendation engines. Okay, so they keep on improving as more consumption happens. In order to do that, what we do is we try to semantically understand the content. Okay, so instead of really going through recommendation for early phase of a post, we try to semantically understand. So you can say one way of could be the classification. You just create some classes, and then if somebody sees sports, you show them further videos of sports. That is one way. But this is very obvious thing that it's not about classes. I mean, maybe face identification can also help, right? So if you're seeing something from Virat Kohli, you might like to see more of it. Similarly, if you like some kind of songs and all, because songs represent some moods, right? So if you go to like a 1990 Bollywood song, then it's obvious that maybe if I show you something similar, you may like it, right? So audio plays an important role. Similarly, dance forms, number of people, emotion. So it's not about classification. It is about holistically understanding the multimodal content. That is what we aim for at ShareChat. That we want to know everything about the video. We just don't want to know the classes. So one way is that you take all of these different lenses from which you can see data, right? Like genre, emotion, audio, video, and you fuse them all together, and then train a classifier, right? So let's say I can have a classifier which says group dance, male dance, female dance, husband wife romance, girlfriend boyfriend romance. So just keep coming up with these categories. So we do this honestly. So currently we do this because this is the first step to this holistic understanding of video, because this is necessary. But then the problem that we are facing is, how do we label this data? Like how many categories should take, which categories? Because every day you see a video, it seems to be belonging to a new category. Just the way people do content is very, very wide. It's not some 50 things that people make. There are like maybe 5,000 things people make, and the more you analyze your content, it keeps on changing. And then we have this problem of long tail content. So a lot of this very specific content does not have videos. So you can imagine that making this classifier is very, very difficult. So what we are trying to adapt is, we are trying to adapt this whole direction of work, which is a cluster and classifier. So the idea here is that do not label the data, cluster the data. And when you cluster the data, it automatically tells you what are the common patterns in the data. Okay. And then you train for this cluster. Okay. So what happens here is that every cluster may not represent a manually understandable content, but it defines one of the mode in the content. Okay. So this is the multiple papers here. I just put the first one here. But this is a very interesting field going ahead, where your content is not very clearly defined. So you
Yeah.
can
So just to summarize, this is a major unique use case that the output classes, the categories are the number of categories is huge. It keeps on changing. Plus, there's long tail distribution. So
yeah,
all the worst case reality
yes,
problems
yeah,
are right here. And the approach that you have taken is to form these clusters and classify based on them rather
yeah,
than explicitly having these classes.
yeah.
And so you're going to talk more about this, or
Yes, so currently what is in, let's say, you call production is the previous approach, where we took the categories to just understand the data. But this is something which is going on right now, because we realize that we cannot go like that, right? So this is an ongoing effort wherein we would like our models to learn from the data themselves, train them, and then start recommending. The other interesting thing that we are carrying out is this one. This is also very unique. So all of this we are doing for recommendation, right? So why not predict if the post will be viral or not? So this is a very interesting new problem. I think a lot of people have looked at from aesthetics point of view and other point of views, but you have to connect this to recommendation engine gradually. So if I can do this, then I don't need to understand anything. If I can just say, okay, this will be a viral post, put it on top, it's done, right? So, so we have these embeddings which are learned by the recommendation systems, and we are trying to align these two embeddings which are in different space: the content embedding, let's say resonate feature, and the embedding from the recommendation system. So if you can find the right transformation, there are high chance that you can take a content and predict whether it is going to be popular or not. So this is also part of the ongoing effort, wherein the quality of the poll, the engagement is getting predicted. So we're finding it very difficult, honestly, because virality is very very vague, right? It's nothing about content. I mean, same content, if let's say a big actress does, it becomes viral. If same thing I make, it will not go viral. So it's not about the content, it's about a lot of factors, and we are trying to identify what factors that could be. So this is a very very unique ShareChat specific problem, or recommendation specific problem, that we are trying to solve.
are there any open source virality predictors that actually work, or papers where they have been successful?
Yes, but these have been very generic things. So for example, people say that if there is a lot of motion, I mean, something nice is happening, right? So it's very dependent upon what kind of data is coming on your platform. So in our platform, a lot of people just stand and make videos. So it's not about motion anymore. There's something else. I mean, so we don't know it yet. You guys, I mean, anybody would, I would love to hear suggestions, like why do you think a post becomes viral? And it's very difficult. So one thing that we definitely realize is that it is something to do with creator. So if you take creator representation, because some creators are good, I mean, their post will get viral. But then what happens is they are anyway famous, right? So even if we don't do anything, they will anyway become good. But the problem is a new person who's making a very nice content, how to help him, right? So it's easy to make Salman Khan movie hit, but anybody, let's say Rajkumar Rao, I mean, it will find it a little harder to get a hit movie, right? Because it has to come to the right platform so that people can see and appreciate it, right?
Yeah. So there's a cold start problem, and then
Yeah.
when you're already an influencer, you have a higher weight.
Yeah.
But are those features being talked about in any papers, or
Yeah. So features are regarding, let's say, you can take the optical flow. The other could be, if your optical flow is very expensive, then you can take the difference between two consecutive frames. And then, some people say that if there are, if you cluster the data of a video, let's say cluster all the frames, and if you find too many clusters, then a lot of stuff is happening. Now, it all depends on your data, whether a lot is good or a concentrated kind of video is good for you. So it all depends on your platform, the data, and what kind of things become viral on your platform. So we are investigating this, yes. So I think one example came up was that if I put a video in which fan is running, now it has very high optical flow, but no aesthetics, no virality factor. So can motion really say it? We don't know. I mean, yet. I mean,
it looks like existing approaches are biased towards motion, and there are other features that could be used.
yeah. Or you just label the data. I mean, just label that this became viral and just run a classifier or a regressor. And so we are trying to.
There are a couple of questions already, so maybe you can read through them or answer them when you want to.
Yeah. Yeah, Rohit. So if when it comes to multiple languages, I think we are pretty. Uh, with we, I mean the NLP community is very advanced these days, right? With these multimodal transformers, right? Multilingual transformers like mbert, XL mbert, and people have trained for Indian languages also. So I would assume that this will not be an issue coming forward. Like once you have enough unsupervised data for all the languages, I am hoping that models will be fine. But they will make a mistake. When I say fine, it's not 100%. But I think still it should be model should be able to handle it. And other thing that so we have not used it yet, but we get to know the language of the video. Okay, because we know from where it is coming, what is the language setting in the mobile phone. So if really push comes to shove, we can also use that information to use the right model. Yes, and yeah, Rima. So this is a very nice question. I mean, very less people ask this. That in cluster and classify, the cluster labels may change, right? So one thing is that the paper shows it still works. So guys, what Rima is asking, what can happen is that all the dogs may go to cluster one in first iteration, and in second iteration, cluster two might become dogs, right? Because clustering does not have this, sense of permanence. Every time you cluster, it will be new thing. So how will model learn? So one thing that paper shows is that even with this, it works out. Okay, and then there are follow-up work in this. What they do is they also add a penalty. So if the index changes from this to this, they have a penalty there. Okay, so they call it like I think skip horn or snip horn thing from Oxford VGG group. I think Andre Valdadi group. They are doing a lot of work in this. So probably I'll after the session I'll share that paper with you. So this is a nice question and they have shown a nice elegant solution to it. Very mathematical, but yeah, it can work. But even without that, people show that it works. It does be very. Yeah, so virality could be clicks, views, reshares, successful watches. I think these could be the ones. Apart from that, I'm not sure. I mean, so virality is pretty much depending on how many people are watching the video or completing the whole video. Okay, and then maybe yeah. So yeah. So I think now let's move to the cool part. I took a lot of time. I'll just move a little faster now. So let us solution. So what we want? We want an accurate model, fast model, data efficient, and continual learning. Okay, so we want all of this, right? Because the scale is high, the data cannot be labeled, as well as the trends are changing. So you want the model to be continually learning. Okay, so let's talk about the multimodal content. I think people asked this question earlier. So most of the video content has one visual component, audio, sometimes text, as well as other signals. Other signals are, as I mentioned, let's say who is creating the video. So in order to understand this video, you have to take care of all of these parameters. You cannot just take visual and understand it, right? For example, yeah, like a popular creator would not create a IBC content. So in such situation, the signal of a creator is very important. For example, like if you see this, the text is saying something else, the visual is something else. If you only do text analysis, you may go wrong here. So you have to have a multimodal understanding of things. Similarly, you have to do temporal because video is temporal. So if you reverse the frame, shuffle the frame, you guys pretty much understand, right? The videos have this problem of ready to model temporal things. Similarly, for audio, you have to do it. For text, you have to do it. So you cannot just do frame level stuff here. You have to have temporal models. So you have to extract spatiotemporal features, and then you have to fuse them in the right way, and then train it. Right. So we use like 3D convolution based networks. You can take let's say Resnix 3D, 3D CNN, i3D. There's a lot of things right now, and you can take whichever works for you. And then for feature extraction, we take a VG kind of feature, which works on the spectrogram of the audio and gives you some features from it. And for text, obviously, you can try BERT, fast text, mbert, whatever, like whichever suits your thing. And yeah, future is very important for us. So once you have all the features, you have to fuse them. So we try a couple of strategies. One is early fusion, wherein you add all the things together in the initial stage. Either add them or concatenate them and train the model. So what the advantage here is that you allow the model to model the relationship between the modalities. Okay, but the problem that happens is there are different dimension and scales at which modalities are. So maybe the audio is maybe in high values, but video might be very small in values. So if you don't take care, then early fusion hurts you. The late fusion is when you allow all the modalities to train themselves, and then you combine their decision. So now the advantage here is that you are allowing each modality its own space, and But the problem here is that some modalities are very noisy for some kind of data. So in the first one, we are allowing the model to decide which is more important in some sense. In second one, we are giving everybody equal weightage. So what happens, there are pros and cons between these two approaches. So this diagram will be clear it a little bit. So on the left, we are seeing early fusion. So you took video, you took audio, text, represent it in some way, concatenate, and then train a classifier. On the right, you are seeing an example of late fusion, wherein you train classifiers for everybody separately, and then you do a fusion over it. So you can summate, you can also add a linear layer here. That is what we do. We have a linear layer here, which kind of learns to combine the outputs of all the models, all the modalities. The other thing that we are trying right now is attention based fusion. So if you see in BERT, you have this QVA, right? So similarly here you can have a query value and attention kind of system that we are trying, and the gating is another thing. So there are a few papers around better way of combining the modalities, because whether you do early or whether you late, you're doing late fusion. In both, you are sticking to a prior information, right? Like you have induced a bias in your network already. So these things kind of help you in reducing the bias. Okay, so they are more smarter ways, and we are trying that. And the other thing that we are trying to do is multitask training, because we all know, right, a lot of good papers are coming in multitask. So if I can do everything with the same model, it will also help me in production, as well as it will also help the model to learn from other tasks also. Okay. Yeah. Okay, so I think now I'll hand over to Rishubh. I have already taken too much of time, and let's go further and deeper, and we'll keep answering the questions as in they come. Okay, Rishubh, over to you.
Yeah, thank you, Vikram, for this introduction, and it was good. Like mostly, we have covered quite a good things here. Now, let's say we have trained accurate models. Now, the part comes: how can we deploy them for the volume of posts that we are seeing each day? Like it's 4 million posts each day are being uploaded on ShareChat and Moj. So we
let me just so I think we are making a transition here. So Vikram covered a lot about how to encode those models and different modes encoded differently, combined, fused in different ways. So are there any questions about that, audience? So I mean, even though Vikram went, what's the word, glided over it very smoothly, there are tremendous amount of details there. Each of those, each mode deserve its own attention, and then when you combine them, maybe one question I have is that, do you actually, I mean, since relating the text to a video is you could have arbitrary text, just together with an arbitrary video, right? The one, like, you could have a man moving the box, but the title below says "lazy fox jumping over the water."
Yeah.
So is there any interpretability to the system, the features that you have, that can you, when you match, for example, if you match sentences, you can match word by word and say that, okay, if these two things are similar, then some of the words would be similar. And in the context of having video and text, is there any sense of matching, intuitive sense of matching that you have or have developed, or these systems are pretty much black boxes that get trained on huge amount of data and then they work thankfully correctly?
Yeah. So I think it's an interesting question around explainability, and that is one effort which has not honestly yet started here. So I think in next quarter that will be one of the major challenge. So right now we are, we're struggling to serve the users the kind of content that we are getting. So right now it's all focused on making the best possible models, and then maybe next quarter it will be around. So whenever we are seeing attention, I think a lot of us know this, that once you have attention in your models, automatically some explainability kicks in, right? You will, so if you take word, you will be able to understand which word was given more importance. But visual models usually not that much. So we are also moving towards transformers now, right? So it's the talk of the town. So I think that will also help us in getting to know which part of the video was seen for making a prediction.
Yeah. So we're going that.
Yeah.
Okay, sounds good. Yeah. So Rishubh, please feel free to. continue. There are some more questions about how the fusion and
Yeah, we will take it up after this, probably in after 10 minutes.
yeah. Sorry, guys. We have a bit relaxed style of these seminars, and allow the audience to ask questions as well as the speakers to explain it. So the video will be available on YouTube on our channel, so you can also revisit it. And or feel free to stay back, or I hope the speakers will share some details if you want to ask more questions to them. Sounds good. Yeah. Please, Rishubh. Yeah. Go ahead.
Yeah, thank you. Once we have developed these accurate models, now it's time to deploy these models. So many things we have to keep in consideration. First of all, being like there are more than 4 million posts being uploaded each day on both ShareChat and Moj. So we have to process them at timely fashion. So for both the problems that Vikram discussed earlier, the IVC detection and cold start problem. So for IVC, we need to detect any IVC content as soon as it has been created and published on the platform. Otherwise, it can become viral and give bad user experience. And also for recommendation, once we have a new post, we want to recommend it as soon as possible. So there are multiple choices when we have to make once we have developed a model, how to deploy it. So like most of these feature extractors that that Vikram was talking about are mostly deep learning based, and GPUs are the choice for them, choice to be used. But again, we have to think about it like if we are using 10 CPUs versus one GPU, so we have to do cost comparison, and if we can process 10 posts parallelly through 10 CPU machines, which is cheaper as compared to one GPU machine. It is better to go with CPUs. So those kind of trade-offs have to be done for each model when we deploy them. And also, apart from model being faster, there is another aspect of the overall system being efficient. So, for video processing, video model inference is one part, but the video decoding is another important part. And what we have observed is sometimes it takes same amount of time on the machine as the model inference part. So we try to optimize that as well. So these are the libraries decode and NVDEC we use. So this performs decoding on GPU, which give us faster decoding after that model inference is performed. One more important thing is like people are uploading videos of large length as well, like 2 minutes, 3 minutes, and at the same time the videos could have very high quality, like HD quality videos. So it should not happen if we process any video. It should not clog the pipeline because it is too heavy or has too many frames in it. So we subsample the video to fix number of frames. After that, by selecting some keyframes, after that we perform spatial resampling to resize them to a fixed dimension, then feed into our networks to get a consistent throughput across the system. So yeah, this diagram shows the decoding part of videos. So let's say if we consider OpenCV as the baseline version, this decode gives 2.3 approximately 2.3 times more faster decodes of video in sequential rate, as well as in training it gives 6 times more speed up than the OpenCV version. So decode is important, and we use these libraries like decode to do faster decodes of the video. So for keyframe extraction, this is the general framework that we use. So for any given input video, we first remove the low quality frame. So this is a standard algorithm that is used named Hecate for multiple places to extract non-blurry distinct frames, so that can represent the whole video. So once keyframe extraction is done, we can perform any other things like OCR is one of the important things where we have to extract text from which is embedded on the image. So we can't do complete on all the frames of the video. So we first extract keyframes and do OCR on top of that. Also, we use these frames for some of the other tasks like IVC detection. So yeah, so Now, once we have the system ready, we have to make design choices for the model architecture. What kind of architectures do we want to explore, such that they are efficient yet accurate? So, in this chart, we can see there. This diagram shows the top one ImageNet accuracy versus the number of flops. So there are multiple model architectures. You can see like squeeze and excitation blocks and mobile net. These kind of architectures are very efficient as they have very low computations but have high accuracy. On the other hand, VGG and VGG set of networks have high number of flops but lower accuracies. So these choices we make before starting any of these model deployments. So yeah, so on respect to video, so videos have spatial as well as temporal information present, right? So given any 2D image CNN, any 2D CNN architecture, we can use them for videos by extracting keyframes and passing each of these keyframe to 2D CNN and finally fusing the outputs. But the main information in temporal dimension is being lost in treating a video such way. So 3D CNNs are the way to go, where they model both the spatial and temporal information together, and this in practice performs really well then using only 2D convolution. But at the same time, we can see these 3D filters have 3 dimensions and have lot many more parameters for the same number of inputs and output channels. So 3D convolutions are good, but they are compute heavy and also consume a lot of memory on the model size. So there are some innovative methods like temporal shift modules that try to induce this temporal relationship into 2D networks only. So in this diagram, we can see there are let's say these are 3 frames from a given video, and and we are passing all of these frames through a 2D CNN network. So one way is to just pass through them and finally fuse the features at the final prediction. But here what they try to do is, after each layer of convolution, they shift the features from the frame width time point t to the frame width time point t plus 1. So here we can see the features are being shifted in the red color we can see. So it gives some, and for next layer it will have information from this time point as well as from the previous time point. So it gives it provides information of the previous. So one could do other way also, like taking the information from the next time point as well, and this works really well, like, and so it is able to model the temporal information as well. So this gives a lot of boost as compared to 2D CNN. At the same time, this is very efficient as well, like we only have to do one shift operation, which is not very heavy as compared to the standard 2D CNNs. So yeah. So yeah, once we have selected the model architecture that we want to work on and trained the model architecture for our task, now one way is to prune the network or compress the network once it is being trained. So there are approaches like network pruning and weight quantization, where we can compress that already trained network and use it for deployment. So in network pruning, what we can do is so for instance, here we have a fully connected network. We can remove some connections which are not important for the final predictions, as well as we can remove the neurons that that don't capture much of the information from the input. So network pruning reduces the model size as well as increases the overall inference time of the network. Also, so we can perform weight quantization, where we can reduce the precision of each weight. So generally, the weights of the network are stored in floating point 32. We can reduce it to int 8 or something like that by quantizing them and using them for the deployment. But like we can see, we are losing a lot of information by doing pruning and quantization, so accuracy may drop. So for that part, the model is retrained and again pruned. So this is an iterative process, and after that, finally hopefully we'll get a model which is kind of having similar accuracy, but the model size is reduced by a lot. So yeah, so another approach is knowledge distillation for model compression. So these three techniques can be used together as well, and each try to optimize for a different thing for compressing the network. So ideally, pruning, quantization, and knowledge distillation should be used together to get the best out of all the words. And so the idea of distillation is to train a very heavy, large network and distill the knowledge from the larger network to the smaller network. And yeah, so one more point here, like pruning and quantization has to be um, done on the same network once the network is trained. But for knowledge distillation, we can use completely different network to distill the knowledge from a larger network to a smaller network. So yeah, so the idea of knowledge distillation is like comes from nature. Um, So like many insects have two forms. One form is larva form that is optimized for extracting energy and nutrients from environment, and another form which is optimized for travel and other purposes. So the idea is to have two networks. One is a very cumbersome network that tries to extract the structure from the data, and another small network that is optimized for faster inference. So once we have trained the cumbersome network, we will try to train the smaller network with the help of this larger network through the technique called distillation. And finally, we will use the smaller network for deployment. So yeah, the basic idea of knowledge distillation is, so we have two network. One is a larger teacher network. So it has high capacity. So by larger, I mean it has lot many layers. And as it has lot many layers, it can explore the search space, parameter search space well, and it will have very high accuracy trained for long enough time. And there is a smaller network, student network, which has very low capacity. And if we train separately the teacher network and student network, the student network doesn't have that much capacity to learn very complex functions. So what we'll do is in knowledge distillation, what is done is, so for this teacher network, we'll train it for very long time with large amount of data. So teacher network can be as complex as you want. So we can train it on multiple GPUs and whatever, because finally we have to deploy only the student network. So the first goal is to train the teacher network as well as we can. So once we train the teacher network, we try to impart this learned knowledge to the student network. And finally, once the student network is trained, it is deployed on the machine or whatever. So the student network, ideally the student network should have more accuracy as compared to training it directly in a supervised fashion without any teacher. And it is proved in practice, like it gets some boost by training in a knowledge distillation fashion. So yeah, this is the steps that we have to follow for knowledge distillation. First, we will train a teacher model with labeled data. This can be large amount of data as well. And after that, we'll freeze the teacher model, freeze the weights of the teacher model, and train the student model with two losses. One loss would be from the ground truth prediction. So one loss would be taking the consistency with the ground truth, and another would be consistency taking the consistency with the teacher's prediction. So for training the student model, we can have the same training set as that of the teacher, or we can have a different training set which is called transfer set. So this transfer set could be smaller than the actual size of the training set that we use to train the teacher. So, yeah. So how does training with teacher help the network? So the predictions of teachers are given by the softmax formula, where ZA are the logics and T is the temperature term. Okay, and so the prediction of teachers are called soft targets, as it has probability of each of the classes from the, let's say, for classification task. And this temperature parameter controls how smooth is the probability distribution among these classes. So if we have very small, let's say T equals to 1, which is a standard temperature value that is used to train these networks. So we can see it is very peaky. For class 2, we have very high probabilities. For other class, it is very low. and if we increase the temperature value to large values, it gives us smoother distribution over the class probabilities. So yeah. We already have ground truths to train with. Now, how does this teacher prediction helps us in training? So in the first row, we can see there is this one hot encoded output with where for a classification task among 4 categories: dog, cat, car, and truck. And dog has the image has the label dog. So for one hot encoded vector, we can see dog is given 1 and others are 0, and there is no information across the classes, right? So there is no information present how is dog related to cat and how is car related to truck or something like that. But once we have trained the teacher network, it has learned to gather information among the class similarities as well. So in second row we can see so second row represents the prediction from a well-trained teacher network, where we have 0.6 and 0.3 for dog and cat respectively, and 0.02 and 0.08 for car and truck. So here we can see like dog looks very much like it looks similar to cat, and hence the probabilities are also quite high. On the other hand, car and truck, so given the ground truth image of dog, car and truck are very less likely and they have some kind of relation. So this kind of information is not present in one hot encoded vectors. So training the student model with additional soft labels like these help him help it learn the knowledge of this class similarities among them. And finally, in the third row, we can see this is the teacher network which is not trained appropriately. So here we can see the dog and car have high probabilities for a ground truth image of dog. So using such a teacher network could even reduce the performance of the student network. So the idea is to first train the teacher network really well. After that, we can use it to perform distillation on the student model. So,
so you mean that the actual labels help instead of the teacher to help the student instead of, if it was just the teacher who was helping the student, then student would have failed at dog versus cat, but it's the actual labels that help student be more correct. Is that what you?
Right. So yeah, so if we have only the ground truth labels, then the student will not learn directly from the ground truth, because although it will learn this is a dog class, but it will not learn similarities among the dog and cat or any other classes. But if we have this additional information of soft labels one, wherein we got to know dog and cat are more likely for this picture, so it will learn some like dog and cat have similar features and they will have 4 legs and so on. So this kind of information is imparted from the teacher to student. So yeah, in principle, this teacher network could be anything. Like it can be a very bigger network, it can be ensemble of various networks, or it can be a completely different architecture as well. So what we did for IVC detection is, as we have discussed earlier, 3D models perform really well. So we trained a ResNext 3D network with 101 layers, which is a very heavy network to be deployed for this task. So once we train this 3D network and for the whole video and consider it as a teacher to train a smaller student network, then the student network was just simply frame-based model. So this frame-based model doesn't have much of temporal information in place. So it will try to learn this information through the learnings of the teacher network. So by training through this approach, we got a lot of gains on the frame-based models, and this frame-based model was finally deployed in production. Okay, I think we can take some questions here.
So there are a couple of questions about quantization-aware training, knowledge distillation with multiple languages. I think there was a question earlier about how much metric gains do you expect from unimodal to multimodal?
Okay, yeah. So about unimodal, multimodal, probably I'll take it. So from the classification task, we see around 8 to 10% improvement by taking audio. Okay. because what happens is that the kind of content that we get, the audio plays a very, very important role. So if you are, let's say, making a funny video, then there are some very peculiar, laughing sounds and background sounds that play around. So maybe visual something else might be happening, but this sound will be very important. So
Is,
that's
is, is there a leading mode? I'm assuming the answer would be no. Meaning that if you always take that mode, you'll be 60-70% right. Video versus audio, is it like that?
so it does not happen that often, but yeah, video plays more important role than audio.
Yes.
Yeah.
Okay. And do you have an ontology for the classes?
Yeah, we have an ontology, and we're trying to gradually build up that. So we so theoretically we have everything now, but then we have to collect data for each of this label data. So we have this whole understanding of a tree, which shows how our content actually is there on the platform.
And you guys have come up with that ontology from scratch based on the data that you've seen.
Yes. So let's say a comedy is there, then it can be, let's say, comedy by a male, by female, by a group. So that way we can drill down as we depending upon how much fine we want to go there.
And do you have to, my questions also don't, do you have to restart the ontology building anytime? Or throw away a part of the tree and, okay,
Yeah, we have to because since the content is ever evolving, what might happen after a certain time is you realize, oh man, I mean, this could also have happened, right? So let's say today, I mean, let's say in comedy you will not see devotional posts, but maybe in future if that comes in, then you have to break the tree and you have to reattach the branches accordingly. So it will keep on changing, I guess.
And then there are a couple of questions about distillation. Have you about quantization aware training? Have you tried that? Knowledge distillation versus directly training the student model. That's one way. And maybe I can also add distillation versus pruning and quantization. So if you didn't do pruning quantization and just did distillation versus what will happen. So a couple of questions for you, Rishubh. Please answer them as.
Yeah, right. So in principle, distillation is different than pruning and weight quantization, and these can be used together. We started with distillation as it is a first step to decide on the architecture and try to get maximum accuracy on the student network. After that, we can try pruning quantization. Also, we haven't explored the area of quantization aware training, but it is in the future steps. So once we have trained the student model correctly, we'll try to train with quantization aware training. And on the other part, so the student model obviously performs better than the supervised training of without teacher that we have observed, and we have achieved 7 to 8% gains in recall on this IVC detection. And another question. Sorry, Nishant, you were saying the last question.
I forgot the order in which I was asking. So
So it was your question.
Yeah, I think it was about knowledge distillation versus pruning and
versus pruning quantization. If you didn't do distillation, only did pruning quantization, you would manage to reduce the size of the model still, right? And
Yeah, right.
accuracy is changing. Yeah. So there are a couple of trade-offs here. Accuracy, retaining the accuracy, retaining or reducing the size to the maximum. So I'm trying to just get a overview of that space of you did one versus others.
Right. So, like I said, these pruning and quantization aware training could be done just after distillation as well. We have compressed the network. So there are two choices. One is the architecture choice that we have to take during the distillation. What is the student network we want to get? For that particular architecture, we are trying to maximize the juice and get the highest accuracy possible through distillation, more than supervised training. Once that is done, we can perform quantization aware training or pruning to make that architecture more lightweight or sparser.
So sounds like you're keeping those things orthogonal. You're first focusing on accuracy and then focusing on compressing.
Right.
Yeah. And just to add to it, how I see distillation is very different from quantization and pruning, because when you do quantization and pruning, if you're starting from, let's say, a 100-layer network and your pruning factor is 10%, then you can only go till 90. What distillation allows you to do it, go to 10 maybe directly, because you can train a transformer from a LSTM or vice versa, right? So we feel that this is much stronger concept than pruning and quantization. I mean, you can anyway do pruning quantization, but it will only give you first a drop in accuracy and relative change in the model size. But distillation can completely kill it off. I mean, it can just drop all the way.
Yeah.
Much
Yeah.
faster.
So then another way to put it is that is distillation enough in itself? After distillation, maybe you don't need at least pruning. You can just go down to the smaller model. Does that hold in practice or not?
So I think pruning will always give you some speed up, some drop. So it will never be that pruning will not stop working. But it just depends how much throughput you want, and if distillation can give you that, it's fine. Otherwise, you can further go down.
And did we miss any question? There's a question about coming up with neural processing unit or specialized accelerators for maybe video, or have you considered that as just the normal GPUs with the particular decoder that you're using? That is good enough.
I think for training that is good enough. And one of our team is also working on device models right now. So they would be focusing more on using the power of the smartphones.
Then I think last question is how much role product managers play in defining these ontologies?
A lot. A lot. I mean, so they do it the most of the hard work here. I think most of the grunt work is done by them. I mean, they will say do all the SQL inquiries and all to understand what are the videos, what are the types, right? So they play a very important role, and they also play a very important role in defining which one to take first, right? So if your tree has let's say thousands of leaves, you cannot go all guns blazing, right? I mean, you cannot collect that much data. You don't even know what you need. So our product managers tell us, these are the important things. If you do good here, we will be able to improve the and let's say the matrix in a better way. And product managers drive a lot around these kind of choices.
Yeah, I hope we've covered all the questions. If you are in the audience still and we have missed your question, please raise your hand or type your questions again. Yeah.
So I think I will start now.
Yes, please.
Yeah, so another important part is having data efficient models. So we have done accurate, we have done lightweight. Now, what about the data and how can we use unlabeled data specifically? So to train these models very accurately, we need large amount of labeled data. And on ShareChat and Moj, like I mentioned, there are more millions of posts uploaded each day. So it is not possible to manually annotate each of these data points. And also for some of the data type, the annotation is very difficult or time consuming. For instance, if one has to annotate what category for this video is, let's say half is singing and half is dancing, it takes time to and some judgment to give it a correct label. So again, pointing on the same thing, manual curation is kind of very difficult. So by manual curation, I mean like let's say we have to train a classifier. Now we have to for each of the classes we need some number of data samples, right? And manually selecting these data points without reviewing is kind of impossible. So one could do random sampling of all the data and then assign these class labels, but random sampling will miss most of the classes, some of the classes which are very specific to that category, or it could also miss some of the very rare categories as well. So and also if we do random sampling, there is this class imbalance problem. For instance, this IVC content is less than 1% of the overall data of the platform. So if we just randomly sample X amount of data, then we have very huge class imbalance to train with, to start with training the network. And also for cold start problem as well, there are some long-tailed classes which have very less data points. So random sampling could again miss those data points. And manual annotation again is costly and difficult, and also we have to train the annotators regularly to get very accurate labels. So for instance, for IVC detection, we have multiple of fine grained categories such as gore, violence, and NSFW nudity, suggestive nudity, all these kind of things, clickbait, spams. So it requires training to them, like what is one kind of post and what is another kind of post, and it is sometimes very confusing even to us, like which category does this data belongs to. So yeah, so all in all, this creating label data is very challenging at this scale. So we try to use unlabeled data. So as we have lot of posts uploaded, we have lot of unlabeled data, right? And can we use these to train our models? So we leverage semi-supervised learning, which is kind of combination of supervised and unsupervised learning. And which basically in semi-supervised learning, what is done is we use small amount of labeled data along with large amounts of unlabeled data and try to build a model using both the labeled and unlabeled data. And so the idea is to leverage the structure present in the unlabeled data and their relationships among themselves. So for all the semi-supervised, most common semi-supervised techniques, there are three concepts that are used. First is induction. So induction is given x and y pairs. You will try to approximate a function that justifies these x and y mappings. Another one is deduction. So given this function, how can you create new mappings for a given set of input? And finally, a transduction. So given x and y mapping, you don't know the function, you don't even try to approximate the function, you will just give the labels to the new set of data points. So this gives so this starts with two semi-supervised learning approaches, which are primary for any unlabeled data training. First is transductive learning, in which, like I mentioned, transduction is used, where we have x comma y pairs and we'll just give labels to the new set of x data input. So for this, first a similarity graph is created between the data points. So using some kind of representation for each of the data points, we compute the similarity between them and create the similarity graph. And once this similarity graph is created, we predict labels for any new data point based on its neighbors and at how much distance those particular data points are there in that representation space. So here we are so here we are not training any model directly. We just take kind of nearest neighbor, first compute the graph and predict the labels for unlabeled data points. Another one was inductive learning, where we first train the model on the labeled data and use the learned model to predict on the unlabeled data. So here we have trained a classifier in a supervised fashion on the small amount of labeled data. Once it is trained, we'll use it to give pseudo labels to the unlabeled data and repeat this process over and over to retrain the model with a combination of labeled as well as the unlabeled data. But yeah, like from inductive learning, it looks easy to just directly, like it looks like we have solved the unlabeled data problem and it should work always. But that is not the case. Like it depends on the quantity and the quality of the labeled data you have. So those label samples, although they are very less, it should cover cover most of the cases in the real world example. If that is not the case, even the pseudo labels will be wrong. So for instance, if we have labeled data where we have only two kind of examples, green grapes and blackberries. If we have trained with this labeled data and assigned pseudo labels to all the data set, finally the testing side, when we get this black grapes image, we'll predict it as blackberries because we haven't seen this, and even the pseudo labels were of either berries or green grapes. Also, we can see the prediction would be much more confident as well. So it can give confident predictions, but those will be wrong. So one has to take care of things before training a semi-supervised network. So yeah, so our approaches could be like in inductive semi-supervised learning we have mentioned, there is one model that first assigns the pseudo label. So the pseudo label assignment can be done in other ways as well. We can train ensemble of models, as ensemble of models are have shown great improvement in performance, classification, and other tasks. One can use ensemble to assign pseudo labels, and finally those labels can be used for retraining the model. Now again, if we use ensemble, it is computationally heavy, like we have to train multiple models with the same data set and so on and so forth. So what we can do is this idea of temporal ensembling, wherein we train a network for let's say k epochs, and we consider each of the model from each of these model trained just after each of these epochs as a separate model, and we can take ensemble of the predictions of these models. So we can take we can predict from the checkpoint from epoch 1, checkpoint from epoch 2, and so on, and take a combination of to get a final pseudo label. But here, like in starting, the network might not have learned very well, so we can use exponential moving average of the predictions to assign a final label, where the recent checkpoints are given more weightage. Okay, so like we have seen, we could perform this temporal ensembling, but the problem there is we have to train for one epoch. After that, we will assign pseudo labels. Again, we will train. Again, we will assign pseudo labels. So for to get the information of pseudo labels used in the training, one has to wait for the complete epoch. So in such a way, so that the model has to wait once the epoch is complete. After then, it will get new set of labels. Maybe it could have realized in halfway only, like these labels are improved and we have new labels, but still it has to wait till the epoch end and to assign the new labels. So in this way, the information is passed very slowly in the main R learning model. So what we could try to do is we could try to update these labels regularly within each epoch as well. But that is a bit difficult to. We have to do one forward pass for all the data points in midpoint of the training or at any point of the training in a single epoch. So there was this idea of mean teacher. What it tries to do is, instead of taking the ensembling of the previous checkpoints of the prediction, it takes it does ensemble the model weights of all the previous iterations. So instead of taking average of the predictions, we'll take average of the model weights to create a new model, which is the teacher model. So this teacher model will be used to assign a label. And like we can say in each epoch, we are having multiple iterations based on the batches, whatever you have. You can keep on updating the weights of this teacher model as the exponential moving average of the weights of all the previous iterations. In this way, what can happen is within one epoch only, we can update the weights of the teacher, or basically the assigning network, and also it can change the labels of the prediction. So yeah, so finally the student model is trained with two losses. One is consistency loss and another is the standard cross entropy. So the consistency loss is between the prediction of the pseudo label, which is the teacher predicted, and the prediction from the base student network. And the cross entropy is between, again, the ground truth and the predicted label. So we can see, like for unlabeled data, we don't have ground truth label. So we'll only use consistency loss between the teacher's prediction and the student prediction. So the student prediction will try to mimic the teacher prediction. So yeah. So this is the overall architecture diagram. We are given any input set of features. The teacher model is there's a teacher model and a student model. The teacher model weights are updated regularly after k epochs by the moving average of the student weights. And the student model is trained with the gradients back propagating from these two loss functions. So we have two loss functions. One is with the ground truth cross entropy, and another with the teacher's prediction, which is consistency between the teachers and the students. So the teacher predictions are here pseudo labels like that we had earlier. So this is an ongoing process. We don't have two steps of first assigning the pseudo labels, then training. The pseudo labels are directly incorporated in this single training mechanism. So we can compute the loss with that.
Yeah, so it seems, sorry if you can go back, seems to have a lot of moving parts here, pick which of the epochs or sub iterations of the teacher model to ensemble and predict the next, pick the pseudo labels, train the student model, maybe observe its performance, and then, I don't know, you're going to give feedback to the teacher also? Or am I jumping to it? So let me repeat the question.
Yeah.
So I think it will be good to know which of the teacher iterations are going to give me a good model, good predictions for the pseudo label, right? If we are doing it on the fly, I'm not sure. It seems to me that there are too many moving parts, too much randomness. We are relying on randomness to give us good pseudo labels. Or you're making it more? Is there a way to make it more deterministic? Yeah, I'm not sure my question was very clear, but yeah, if you can still answer it.
Yeah, right. So the basic idea is like, let's say if we have only the labeled data points, we don't have any unlabeled data points, and the student is trained with just whatever your cross entropy loss, right? And the teacher model is just an ensemble of all the previous models, previous versions of the student model. Okay. So ideally, it should perform. It should give more confident or more good predictions than the student model. This is one step one, and we could directly use the predictions of student only to give the pseudo labels. That is done in the standard inductive learning. But as we know, like ensembles perform better, we take ensembles of the previous iterations of the student model. Now the idea is to, one way is to just have this teacher model as the ensemble of the previous student model, and let's assign it pseudo label. We can use it to retrain the model again. Let after each epoch, let it assign the pseudo labels and do subsequently. But for this, we have to wait for one epoch to get good pseudo labels,
Sure.
right? So instead of doing that, what we can do is we can have this teacher model incorporated directly within each epoch. So instead of an epoch, we'll consider each iteration as a new one, right? And we keep on updating the pseudo labels predicted by the teacher. So basically here we explicitly we don't want to assign pseudo labels. Those are directly incorporated with this loss computing, with the student prediction and teacher prediction.
Nice.
So
the first strategy was to have explicit checkpoints across student models. You think that is very slow. So just have one iteration of training of both teacher and student in parallel, where teacher keeps on generating these proxy labels, and student keeps on learning through them. There seems to be something still missing, but what I said was roughly correct, or?
Yeah. So Nishant, I think one thing is missing here is that in this, so the one which is slow, in that epochs have to be complete, because there for every sample you need the output from different epochs. But here you do not need to do it. So instead of making it a sample as the pivot point, here they have made the model as the pivot point. So they say that instead of waiting for each sample to get multiple predictions, let's add something in the model itself, right? Because in the previous one, what you were doing was fx1 plus alpha of fx2 plus alpha of fx3. Here, what you are doing is you keep the x like that, change the f only. So it is f1, f2, f3 now. So whether you do a function level or you do at the input level, so it's just a different way of looking at it. This way of looking at it makes it easy because the epochs don't have to complete. And the problem is that with current data sets, nobody runs more epochs now, right? It's all about iterations these days. People run just 3 epochs, but data is so huge, so you never get to see maybe the same sample again also at times. So that's where the earlier approach was not practical in current scenario. This has become practical. One more point I want to make here is that the teacher is not trained at all. The gradient never flows to teacher. After some epochs, teacher is just updated with the parameters of the student. So this is not moving part. So teacher is not the moving part here. Teacher is just a storage space for storing, let's say, the student multiple epochs in a weight sense. Right?
Yeah, so that's a important clarification. Yes, but so teacher is sort of a storage point of the previous student models.
Yeah.
But then that is the slow mode of working. In the fast mode that you're talking about,
Fast mode. This is the fast mode, because here every batch the teacher keeps on can be changed. If you
I see. I see. Okay. So maybe that is invariant throughout. The teacher is never updated directly. It's always updated from the student model at that iteration.
Yes.
Is that right? Okay.
Yes.
Okay, that clarifies.
Yeah. So there's no gradient flow in teacher. If you see
I
the
see.
diagram, it's just in student. Yeah. And one more point, maybe I'll have to make that both these have higher dropouts and lot of augmentation. So you never feed the same image. If you feed the same image, then maybe nothing will happen. So both the ensemble, which is teacher, sees, let's say, a rotated image, and the student will see, let's say, a translated image, and they will be expected to come up with this representation. So there's a lot of data augmentation which is going on to learn the concept well.
Sounds very good. Yeah, great clarification. Yeah. Okay. Yeah, please. I think our audience has a few questions also. Ayush.
Yeah. Maybe we just finish it in 2 minutes. Rishubh, we can skip the continual part maybe, and then we'll take questions. I think that is more important probably.
Yeah, sure. So yeah, all in all, this semi-supervised training gives us large improvements on IVC detection, and it provides another way to start training the models, even if we have very less data samples labeled.
We'll skip this part for now. I think let's go to the questions. I think that's much better use of everybody's time, I think.
Or maybe you could just say a few words about that slide and not go into detail.
Okay.
What you skipped.
Yeah. So basically, the main idea of continual learning is like in all of our models, the data keeps on changing, and specifically for IVC content, the creator finds new ways to fool the system such that which is passed by the network. And another is this for cold start as well, like new kind of content is being uploaded every time, and the genres change very rapidly. So this ontology also changes. So it requires multiple rounds of retraining of the models. So we have set up some continual learning pipeline where these networks keep on training after 1 week or so, based on the data distribution change. And there are some evaluation strategies. If the accuracy drops, then we do retraining. Otherwise, we don't. And all of those things.
Yeah.
Yeah, I guess. So yeah, Vikram, you can.
Yeah, so I think, guys, I mean, like in future plans, if I say the problem property is straightforward for us, these are the most important ones. We want to make the best-in-class recommendation system, and especially we want to make it work good at early phase of the post. That is where a lot of value lies for us. Similarly, we want to improve the IVC detection, because whatever we do, there are new ways to fool the system. So we're also trying some kind of keyword spotting in audio domain now, like ASR. So if there are, let's say, some abusive words in the audio, can be directly detected. So that could also be another dimension to the whole IVC detection. And self-supervised and unsupervised will be probably one of the major themes going ahead in this year, because if we fix the data part, I think rest all is figured out. I mean, the data is the major bottleneck, not the models these days. And then model comparison is important. I mean, this 2 million is going to get to 4 million and 6 million and so on and so forth. So this will be a very important challenge going ahead. I mean, 2 million is still easy, I think. And then the data drift. So this kind of platform evolves, right? And once it is evolving, your model should evolve. So these are the common themes which are going ahead in our team these days, and we are every day trying new models, new mechanisms, improving the earlier ones to be on the track. So yeah, so with that, just like say thank you everyone for attending. I mean, it has been a little longer session, too many slides, but hopefully, I mean, there are some take back messages for everyone to just like read, and maybe some good ideas you might have got. Let's be open for questions.
Yeah, thank you again, Vikram and Rishubh. This was both deep and wide talk, and very happy that you guys could take time to the content and to answer the questions. Yeah, and thanks to the audience too. There are a couple of questions, and I guess, Vikram or Rishubh, we can look at
Yeah.
last few.
Okay. So, is there any trade-off inflection point? Yeah, it's still very difficult to say. I mean, this pseudo-label accuracy. I mean, it will depend on the data set, the problem. So I don't think we read a lot of papers, but nobody has that inflection point value. It's very subjective. So, but yeah, I mean, so we'll write a few blogs later once we get that some values for some of the use cases. But it will keep on changing depending upon use case. And how much gain from main teacher? Yeah, so I think we got a lot of gain. So it's about Rishubh, what was the percentage for mean teacher method? I mean, how much gain did we get?
Yeah, approximately it was 10% on the recall values.
Yeah, so that's pretty huge for us for setting. And then abundance of semester. Yeah, I should think we can connect offline also on this. So there are a lot of approaches. I mean, we have just tried to cover one of it. Like let's say what we call a seminal work in one thing, and there are more things like so we're trying adversarial training, virtual adversarial training, which did not work so well for us. There are some failure cases which don't work, and the same technique may not work at multiple places. It's not that mean teacher put everywhere and it starts working, because that problem has to be there first, right? If the task is easy, then maybe the original student model is able to capture everything, and teacher may not help. So it's very dependent upon the problem statements and data. Regarding the data size, everybody again, I mean, it's very subjective. IVC has different data size, topic cold start has different, so everybody has different data sets. But they are big in number, if that is what you meant. So they're not using small data. Like for cold start, we have around 500k videos, so it's pretty huge. It's not small. And you might asking is any cluster and classify approach applied to textual data. So remember, this cluster and classify approach is independent of the modality. And if you want to see, you can see this paper XDC. So XDC will kind of take audio and video into consideration. So I'm not sure if they take text also, but there are multimodal cluster and classify algorithms also. But if you can imagine, I mean, like these days it's all becoming very uniform. Like once you have the BERT embeddings, it's as good as it, right? I mean, like then all the processing remain can be same as before. So I think with these changes, you can apply this into other. Is ShareChat hiring? Of course. Yeah, I mean, yeah, we're hiring, we're expanding. Yeah.
Maybe I should ask Abhishek, are you applying? That's great. I mean, it's great that you guys got to share so much, about the problem, and the audience got to learn. Otherwise, a lot of it just stays behind the door, and people don't learn what they read on these papers on archive every other day. How is all of that applied to real life? Thank you, everybody. Yeah, it was great. Are there any other questions or comments that users have? Yeah, I mean, thumbs up definitely helps us. So yeah, you can the talk. As I said, the talk will be available on the YouTube channel as well as older talks you can go and watch. And if you have any questions, Vikram or Rishubh, would you like to leave any contact or there's a event page on LinkedIn. If you guys have any question, please feel free to write there, and we'll connect you to who can answer these questions.
Okay, cool. Yeah, thank you so much, Nishant, for having us. It was really nice.
Yeah, I hope you guys enjoyed this super long session. This will be there in made permanent on the YouTube channel also, so you can come back and just look at how many questions did you answer.
Yeah.
Thanks again. Yeah, thanks so much for
thank you.
sharing your.
Thank you. Bye, guys.
Thanks, everybody. I'll be closing the session. Bye.